Hopefully. I say quadrant 1, 2, 3, 4, we can locate those. Yeah?
Yeah, I think so.
You think so? I hope so. Let's give people a moment here to get themselves prepped. All right, here we go. So the coordinate plane. Let's make a sketch of it so we know what it is, know where to find everything we need on it. It's important to be able to recognize our positive and our negatives on the coordinate plane, because once we get to the unit circle and when we get to polar coordinates, we're going to make sure we're good to go with that. So as best as you can, make our y and x axis. Let's label it. So we got our x axis, got our y axis. Oh, thanks, Jalen. Do we remember where the origin is?
0, 0.
0, 0. Good. So our origin is right here. Where's quadrant 1?
Top, is it gold?
Top right.
Oh, this is 1.
So quadrant 1. Roman numerals. Then do we go clockwise or counterclockwise?
Clockwise?
Counterclockwise. So 2 is over here. 3 is down here. And then 4 is down here, bottom right.
Oh, yeah.
In quadrant 1, we know that my x is going to be positive and my y is going to be positive, right? In quadrant 2, I know that my x is going to be negative and my y is going to be positive. Quadrant 3, we're at negative, negative. In quadrant 4, we're at positive, negative. Good. All right, and again, that's going to come in handy when we get into our trigonometry and our unit circle. So we want to make sure we're good to go with that. And then we can find any ordered pair within the coordinate plane that is x comma y. Yeah? Okay. Good. Some fancy words that you might want to put in your vocabulary just to make yourself sound smart when you're talking to people. Make yourself really feel like a mathematician. We have the abscissa. Did you ever hear that one before?
Nope.
Well, now you got it in your repertoire. The abscissa is just a fancy word for the x-coordinate. And I threw this definition on here because we're so used to knowing, oh, it's just the x-coordinate. Well, what does that actually mean? The x-coordinate is, it gives the distance and the direction of a point from the y-axis. All right? Your x-coordinate gives the distance and direction from the y-axis. So if my abscissa is positive, what direction from the y-axis is it moving? Right. To the right. If my abscissa is negative, it's moving to the left, right? So if you guys remember back when I introed the right triangle, we were doing right triangle trig in geometry, we only had positive numbers, positive lengths. In pre-calculus, we will get negative lengths, and those negative lengths just tell me that I'm moving to the left side of my y-axis. It doesn't really mean that I'm going negative units. It's just telling me I'm moving to the left. The ordinate is the fancy name for the y-coordinate. And this gives the distance and direction of a point from the x-axis. So if my ordinate is positive, that means I am above the x-axis, so many units. If my ordinate was negative, it's below, right? Well, this makes sense, right? So we're kind of just thinking about it in a better frame of mind. And we're just kind of used to X, Y, X, Y. All right. I'm going to try my best to use these fancy words. You try your best to use these fancy words too. So let's be fancy about it. Instead of just X, be like, oh, that abscissa is really 2 units over. Isn't that fancy? Okay. All righty. So now let's jump into an example. So here we're going to let X represent the number of seconds a robot works. And Y is the number of years of electricity provided for one household. Determine the missing numbers in the chart below and draw a graph of the set of points. I'll give you a second to get it jotted down. And then also I am recording this and we'll immediately post it to our Google Classroom. So if at any point in time you want to revisit anything we talked about, you can just go there and re-listen.
Oh, I see some of the numbers are blank.
Yeah, we got some blanks in there that we're going to fill in. Not really sure why we care about a relationship about the number of seconds a robot works and electricity provided for one household, but that's what the example is.
Mm-hmm. So we can use a graph calculators for this. But we don't necessarily need to, but
Not necessarily. We can.
but we can just look at what the relationship looks like.
Yeah. Okay, so let's talk context here. What technically is my independent variable for the X? Yeah, so I'm just going to put a little note here that that's my seconds. And the reason why I care about that is because we are asked to graph, and remember, tick, tick, label, label, label. So I want to do all of that, so I'm going to just jot it there. My dependent variable, which is my Y, is represented by number of years. Is that what it is? Number of years of electricity, so just number of years. Okay, so now let's fill in the blanks. I'm going from 0, 0 to 31. So it would be 45 to what? How would we figure that out?
Oh, I know.
Go for it, Rowan.
1.5.
How'd you get it?
You just 45 is half of between 30 and 60.
And that's assuming that this is a linear relationship,
Yeah.
right? Doesn't really tell us that it is, but we're going to assume that it is. So Rowan said, oh, I see that from 30 to 60 is 1 to 2. 45 is directly in between, so it has to be half of that. Another way you could do it, if you weren't thinking about that common sensical, that's a word, you could set up a proportion, right? I could do 30 over 1 is equal to 45 over my unknown Y and cross multiply. Or if you're really thinking algebraically, I could use the slope formula and do, if I use these 2 points, I could do 45 minus 30 over Y minus 1 is equal to, what would the slope be if I found the slope between these 2 points? Oh, and I didn't even do this right. This should be flipped, shouldn't it? Ignore that. Flip it. Y over X, Y over X, Y over X. Y minus 1 over 45 minus 30. Sorry about that. Wouldn't my slope be 1/30th? 1 over 30. So I can solve that for Y. Which is easier? The left or the right? The proportion, isn't it? Yeah. So let's do a quick flipperoo of that. So I can flip these guys. So then I get Y is equal to 45 over 30. Some easy proportion work there, which 45 divided by 30 is 1.5. Okay, so we know that this blank is 1.5. I made that table too small. What would this one be? Well, we could do 60 over 2 is equal to 70 over our unknown y. 60 over 2 is 30 is equal to 70 over y. Do a little flipperoo. So I can do that with my rules of proportion. So I get y is equal to 70 over 30. Is that 2 1/3? Yeah. So 2.3. Then do the same thing for 80. I'm going to keep the 60 over 2. 60 over 2 is equal to 80 over my unknown y. So 30 is equal to 80 over y. Do a little flipperoo. Y is equal to 80 over 30. That's 2 2/3, so 2.7. We go to 1 decimal place. All right, so now let's make a graph. I'll do my graph up here. So got my axes. I only care about quadrant 1, y, x. Oh, I should make that a lot bigger. So I got my y, I got my x here. All right, what am I going to... X is seconds. Y-axis is number of years. Jump by, I don't know, tens? Does that seem okay? So 10, 20, 30, 40, 50, 60, 70, 80. My y-axis, I would jump by, what, halves, maybe? So half, 1, 1.5, 2, 2.5, 3. Okay, so it's always important to label what your tick marks are going to be. So 0, 0. 30 and 1. 45. 45 and 1.5. 62. 72 1/3. Oh, I'm getting, and then maybe like right here. That's too high. Okay. They appear to be pretty linear. Yeah, I'd say so if my slope was consistent. There's our line. Okay. Questions with any of that? Good. Now, your calculator can come up with an equation of a line for that really nicely. Do you know how to do that?
No.
You don't?
I was trying to figure out how to draw points on here.
Let's pause from this. Can I delete this? Everybody's got it?
Yeah.
Okay. All right, let's see if I can get my calculator back rocking and rolling. So, does everybody see on their calculator a button that says stat?
Yeah. Yeah.
Yeah, let's highlight it in red up here on the front. There might be some way to make a list. Yeah, go and see where it says stat.
Oh, yeah. Yeah.
There you go. And see if there's some way to make a list. All right, so go into your edit. So enter into edit. Now, you may have numbers in there already. You might have blanks. If you do have numbers, like I do, I'm going to move over. I'm going to highlight L1, and I'm going to clear it out so that my list is cleared. So I want a blank option. And now what I'm going to do is I'm going to put in my X values from that table into list 1. So we had 0, 30, what was it? 45, 60, was it 70 and then 80, I think? Yep, and then our x's were, our y's go into L2, so 0, 1, 1.5, 2, 2.333, 2.6666. A whole bunch of numbers in there. I just put in a whole bunch of 3s and a whole bunch of 6s.
Okay.
So now we have both our x and our y values in a table.
Yeah.
So now what we can do is go back to that stat button. We'll go over to calculate. And if you look at number 4, you see your mx plus b, but ax plus b, which is your linear, it says linear regression. I'm going to go down to number 4. I need to tell my calculator what I want my x list to be. So mine says L2. So I'm going to hit second and 1 to make it L1. If yours is already L1, then you're okay.
It tends to be by default, yeah.
That stuff doesn't pop up.
Yeah, so if yours doesn't pop up for that, then you'll have to hit second number 1. And then the comma, which is above the 7. And then second L2. And then just hit enter, and then it should give you the equation. You guys get that?
I got AX plus it says A is your.
Did you get exactly 0 for your A? No, it shouldn't be 0, right?
No, I got 0.033333.
Because what did we say our slope was? 1/30th?
1/30th, yeah. And then it says a different value for B though.
Well, depending, I guess, how many 6s and 3s you put in. Is this a very, very small number?
I
got 1.3.
Yeah. I mean, that's pretty darn close to 0, wouldn't you say?
Oh, it's negative 3-ish. Yeah, that's not. Well, I mean, if I calculate, I don't know how it showed up.
Isn't some trying to calculate?
Huh?
Or what does it say? Because there's like negative 12. What?
Do these come with like a shoot?
It's like
Answer?
Yeah.
Mine came with a giant like paper of them, but I didn't.
Yeah.
There was so many things on there I got overwhelmed. Yeah. You know what's sad is that I got one of those calculators and I lost it the same day. Dude, this was so expensive. Well, it wasn't like a super expensive one, but it was like, you know. I know what exactly. I figured out how to. That is a phone. Can you play games on that? Yeah, I think so. I want to get games on it. And then print like flatter.
Did you figure it out? Jenny just figured it out.
No.
So go back to that stat option. I go to calculate, and then regression, and then x, and then ax plus b. And you got it.
When I hit, oh my gosh, so cute.
Okay, so number 2, we said have a company is manufacturing a new calculator. Maybe that's where we're going to make our big bucks. Make a new calculator that you can zoom in and out on the graph. Wouldn't that be fantastic? Touchscreen calculator. Why hasn't that come out yet? It's called Desmos. It's called a phone. Yeah, exactly. So manufacturing a new calculator from a market survey, a linear model for the relationship between the demand Y and for the product and the price of X of the product. Oh, I might have wrote a lot of words there that I didn't need. Demand Y for the product. That doesn't make any sense. I must have been going delirious last night. Let's just say that the price of the product. Oh yeah, demand Y for the product. Okay, I'm not losing it. And the price X of the product is developed. Okay, I'm not losing it. Graph the linear model of 4X plus Y equals 330. Okay, so now we're making a graph. Because it is a word problem, there is context. So we're going to do our tick, tick, label, label, label. Give it a second for you guys to get caught up.
Yeah.
So this is an explicit function, meaning that I can solve it for Y. Right? We could solve that for Y and put it into its implicit form. I'm using these words now so we kind of get used to it.
Oh, I see it on
So it's written in standard form right now. I could technically graph it by finding x and y intercepts, right? Yeah, you probably need to zoom out for that one, huh? Because what would be your y-intercept? You covered up your x, wouldn't it be 330? What would be your x-intercept? What is 330 divided by 4? 82.5? That's not too terrible. Okay, so let's jot that down. So we know that my y-intercept is going to be the ordered pair of 0, 330. We know that my x-intercept is going to be 82.5, comma 0. Okay. We could solve it and put it into slope-intercept form. That wouldn't be complicated. That would just be y equals negative 4x plus 330. So now it's an implicit form, meaning that the y is solved for. Okay, let's graph it. Here we go. Do I need any other quadrant besides the quadrant 1? In this real no, right? Because I don't have any negative. I can't have negative price, I guess. I guess you could go in the hole. Some money. All right, so we got our quadrant 1. Got my y-axis. I got my x-axis. We said the independent is the price. So price on the bottom, and the demand is on my y. All right, let's see. I got to get up to 330. What would be a good idea? Jump by 50s. Though my slope is negative 4. What did I do on mine? I jumped by 50s. Okay. So 50, 100, 150, 200, 250, 300, 350, 400. On the bottom, I jumped by 10s. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I'm just going to graph those x and y intercepts. This is how I'm going to do it. So my y-intercept is at 0, 330. So estimate where you think that would be. And then we're down at 82.5. So you're right about there. As best you can. Straight line. Ooh, that was pretty sweet. Beat that, guys. All right, and we would be able to type this into our calculator and graph it. So I would type that in and I would do a zoom 6, but knowing that would get me to 10, 10, 10, 10, so I'd probably have to play with my window a little bit to get up to that 330. So maybe I would have made my y min 400, and I would have made my my y max, 400, and then I would have made my y min like only negative 2, and then I would have made my x max 100, my x min maybe like at negative 2, and then you should see that in the window. Okay? Questions with any of that? All right. We're going to do 2 more graphs, and we'll be done. Quadratic graph. Let's do a quick review of that. We've had one already in our homework, but let's get it in our notes so we have it. If I had to graph the quadratic graph of y equals x squared, we're going to do a quadratic and a cubic, and then we're done. So y equals x squared plus 4x plus 5. I know right away that my c is going to be my y-intercept. So that means we have a y-intercept at 0, 5. And Aoife reminded us earlier that to find the vertex, we do negative b over 2a. Well, it's x equals negative b over 2a. So to find my vertex, I'm going to plug in my b, which in this case is 4. So negative 4 all over 2 times my A, which my A is 1. So the abscissa of my vertex is -2. How do I find the ordinate? Plug it in. So y equals -2 squared plus 4 times -2 plus 5. And if you trust me on that one, it comes out to be 1. So that means my vertex is at -2, 1. All right, so let's make a graph. So my axes, labeling it yx. I'm going to jump by singular tick marks, I guess. 1, 2, 3, -1, -2, -3, 1, 2, 3, 4, 5 to get up to. All right, so -2, 1 is going to be my vertex. I have a y-intercept at 5. And because we know that parabolas are symmetric, this ordered pair is 2 units from the axis of symmetry. Then it's going to be 2 units over this way on the axis of symmetry. So I should add an extra tick mark over there. And then make our parabola. Okay. So that'll be our graph. I'm going to label my vertex, label my y-intercept. I'm going to label this third point, which would be at, what, -4, 5? Okay, so if you remember how to do quadratic graphs, do you remember what a cubic graph looks like? Yeah, it's like the S, right? So a normal cubic graph looks like this. Or that's curvy one, looking one. So can I erase this? We're good? All right, so let's do a cubic graph of -x³ plus 3. So what's this negative going to do to my graph? It's going to flip it, right? So we know that a normal cubic graph is going to look like this. So a negative cubic graph we know is going to be like this, right? Because you reflect it over the x-axis. So this goes down, this goes up, right? All right. Any guesses on what this plus 3 is going to do to it? Moves it up. Good. All right, so this is going to move it up 3. So if it starts at the origin, now we're just going to shift this whole graph up 3. So here we go. If I plug in 0, 1, 2, 3, 4, 5, 1, 2, -1, -2, -2, 1, 2, 3. So I plug in 0, my output's going to be 3, so I've got a point at 0, 3. Oops. If I plug in -1, well, -1 to the third power is -1 times the -1 is +1. 1 plus 3 is 4, so at -1 we're at 4. If I plug in +1, I get 1 to the third is 1. -1 plus 3 is 2. And there's going to be my curve. What would be your x-intercept?
Excuse the interruption. Good morning, Marshwood.
That's right.
In respectful remembrance